So I'm not sure where people are. I'm not sure. Okay, let's continue. So we're gonna take this as example number one. Ne? So I've just taught you to say if they give you this sign, sigma notation, if they give you this sign, sigma, I'm only gonna do one example for this because we did a. It's just that we haven't done the corrections, but I believe most of you understood basically what I was teaching. And if you didn't write, please to, to write that yesterday's work. Ne? So R is equals to 1, and then this one. The reason I'm just continuously doing them is because of they're gonna write them in different notation. So I want you not to get confused, even if even if you see something that you were never, or you were never, how can I put it? Even if you see something that it's vague, or I don't know which term to use, but as long as you are more familiar with what I taught you, I think you won't be able to struggle. Ne? So here, let's say they give you R plus 1. Okay, let me check this thing. I'm just changing with the one that I'm writing with because it's continuously giving me problems. Then let's continue just now. But we are winning. We are on the correct side. So then this one, I hope you will be able to. Yeah, as I was saying, make sure that you master everything that I'm teaching you so that you don't struggle. Ne? So I would have loved to use the board, but I've been standing on TikTok for quite some time, so I'm just a bit tired. But not for you guys. So I'm gonna use this setup, ne? And I believe you will be able to learn. So yeah. So now let's continue. As I was saying, let's say they give you R and then open bracket R plus 1. So what you are going to do always, you must not forget that here, this part always, let me use a different color. The number that is on top of the sigma sign, always, ne? You always end with it, this one. This part, you always end with it. You always end with it. You always end with it, always. Whether you like it or not, you always end with it. And then this one at the bottom of the sigma, I'm just going to use a different color. This one, you always start with it. This one. You're always starting with this one. And then now all of you understand when I'm talking about the number of terms, what do you basically deal with? And this R that you're starting with, you always going to develop a series. Okay? And then when you're developing a series, you always start that R is equals to 1. So here we're supposed to write 1 here. Here, let's write R. It's R plus 1. Must be very careful with regards to that. So now most of you know the concept. So why am I writing this? I'm just writing this for the sake of you to have a clear understanding. Please, guys, don't write on the board. Ne? Please don't write on the board because you will confuse other students. Please don't write on the board. Appreciate if you don't write. Ne? So you always develop a series. You always develop a series. Develop a series. Now let's develop a series. You know that if we were to calculate the number of times, it will be number at the top of the sigma, which is 6. Subtract the number at the bottom, which is 1. You always add 1. So you can actually see that your n, it will be equals to what? It will be equals to 6. So this basically means to say, when you're developing a series, you're going to start where? At R is equals to 1. And then you say R is equals to 2. Then you say R is equals to 3. Please don't write, guys. Ne? Don't write R is equals to 3. Then you say R is equals to 4. Then you say R is equals to 5. And then last, I don't have space. I'm going to say R is equals to 6. So that's what I taught you. I said you develop a series. Now let's develop that series. So as you are developing that series, you understand that we're gonna have what? We're gonna have R into R plus 1. And get, please don't write anything, guys. Plus, and then you say R into R plus 1. Into R plus 1. And then you're gonna say plus R into R plus 1 is always gonna be the concept of you making sure that you develop a series. Plus R into R plus 1. Now, what? How many do we have? 1, 2, 3, 4. Then we are left with 2 plus R into R plus 1. Please don't move the screen. Please don't erase anything. And then lastly, plus the last one, R into R plus 1. You on the other side, what you can do, you make sure that you write them in one line in alignment. It's just that my handwriting is a bit big, and then I'm no longer having space. And then now the first one we're gonna substitute in a place of R. Remember, don't forget, we're gonna substitute by what? We're gonna substitute by what? We started R is equals to 1, remember, Angel?
So,
Yeah, it will be 1 into 1 plus 1. Any question? And then we say plus
2.
2, yes. 2 into 2 plus 1. And then Roirangi plus 3 into 3 plus 1. Right? Plus 4 into 4
4
plus
plus 1.
4 plus 1 plus 5 into 5 plus 1. It's just that I don't have space. Lastly, you'll continue on one line. Plus, you'll also add the last one, which is 6 into 6 plus 1. 6 plus 1. It's just that I'm no longer having space. And then you make sure that you add them in one line. It's just that I don't have space. And then 1. So that will be 1. Okay, let me not rush it. That will be 1. Open bracket, we know that 1 plus 1 is 2. So we'll write 2 here. Plus,
2.
and then that will be 2 into what? Into 3.
3.
Yes. And then you'll say plus. You'll say plus 3 into 4. And get,
4.
guys, don't move the screen. You see, that's the thing that I was talking about. There's someone who's reducing the screen. Please don't move the screen, guys. Because you're gonna confuse other learners. You see, now I'm no longer seeing the screen because there's someone on the screen who's moving my screen. Please don't move anything, guys. Please don't move anything. So leave the screen the way it is. I would appreciate that. Let's continue. 3 plus, and then you're gonna say 4
4 into 5.
into 4. Ne? Welcome UCC2 plus, and then that will be 5 into what? Into 6. Lastly, plus 6 into 7. I hope I didn't do a mistake. And then here, when you come here, you just multiply. You're gonna say 1 times 2, we know that that is gonna be 2. Plus, then 2 times 3, that is gonna be 6. Plus, and then 3 times 4, 4, 8, 12, that is 12. Plus 4 times 5, that is 20. Plus 5 times 6, 12, 18, 24, 30. Plus 7 times 6, 7, 14, 21, 28. That, I think that's 35, if I'm not mistaken.
No, sir.
It's what?
It's what it is, sir.
6, 12, 18, 24, 30. Oh, it's 42.
Yes, sir.
Oh, cool. That's 42. So let's check. We must have 2 plus 12. Yeah, everything now is correct. And then after that, remember, you will write this. Sorry for that. Remember,
Sir,
yes, sigma.
are
Yes,
we gonna be penalized if we do not write the step that you wrote in green?
in green. Yes, you're gonna be penalized. You know why? Oh, you mean the one that I wrote it with green?
Yeah.
No, you might not be penalized, but you must always write it
Okay.
so that you
Okay.
forget. Yeah, it's a good question.
Okay.
So here we are having 6. We all know I taught you. And then this one is r is equals to 1. We all know I taught you. Then here we're having r. Actually, here we're having r into r plus 1. And then they gave us what? We got that series. It's not a sequence because it has plus signs in between. So that is 2 plus 6. You write it properly. And then plus 12 plus there's someone who's, please mute yourself. If there's background noise, please mute yourself. If there's background noise, please mute yourself. And then can you see myself? There's no background noise, and all of you can hear me. There's no disturbance. But if you are in an environment where there's no noise, then you can unmute yourself. I don't mind. Ne? Plus 12, and then here we are having plus 20. Let's continue. And then plus 30 as well. And then plus what? Plus 42. Right? Plus 42. And then from here, guys, what basically you'll be doing, what basically you will do from here. Oh, now let's continue. Now let's continue. So here we're gonna have sigma sign, and then here we're having 6. This is r, it's equals to 1. And then here you can say r into r plus 1. Now r plus 1. Now what we are going to do, you're gonna determine the sum. So what is the summation there? You add everything.
112, sir.
112.
Yes, sir.
Okay, yeah. 112. Cool. So that
Sorry, sir. Can I please ask?
Yes, you're saying?
If you skip the last step, then you go straight to the last step, is it wrong?
No, it's not gonna be wrong. It's not gonna be wrong.
Oh, I
It's
thought
just,
maybe both steps have marks.
yeah, it only depends. You know, people who said maths question papers, it only depends. And you might find that if maybe it's just that I'm not sure all of us here on the live, on the session, we are blacks. I'm a black person. So you know that in some instances apartheid still exists. So if maybe your question paper is marked by someone of a different race and you are getting good grades, they might penalize you for that 1 mark. But if maybe I'm the person who's marking your script, I might not even penalize you. So you know, it only depends on who's marking the question paper. So that's why normally when I'm teaching maths, I don't like jumping steps. Even when you see me teaching on TikTok, I write every step so that you don't get an instance whereby you get 79% level 6 and then you jump to 1 step, then they penalized you for that instead of you were supposed to get a maths distinction. So it only depends on who's teaching you at that particular moment. Yeah, but for you to be on the safe side, make sure that you do what? Make sure that,
Right.
yeah, you write everything. Ne?
Okay, thank you, sir.
Yeah. So now let me show you another concept. So here I'm gonna show you another one whereby they want us to determine the what do you call the sum. Ne? So look at this. Now you understand the concept. Now this we are adding. Now we are going to the next step, but it's still under sigma notation. So I want you now to concentrate on what is a series as well as what is a sequence. So here comes another example, but it's of a different concept. So it's still sigma, we all know. So you might as well write example maybe 2 here or 3. I don't know. Yeah, I think it's example 2. Ne? So this one, please, I'm gonna be as short as I can. Please make sure that you listen to me. So I want this one, ne? 100. It's an interesting one. And yesterday on the WhatsApp group, I sent you those long questions that I wanted you to do. And then I said there are some of those whereby yes, okay, let me mute everyone because there's a background noise. Yeah. So
Sir,
yes, you can ask
can
Martha.
you step-
Yes,
I need to adjust the screen because where you are writing now with the yellow, it's actually beneath my phone and I cannot see.
okay. Please adjust it and then I'm just gonna try to adjust it as well.
Okay, it's fine.
It's now fine.
Yes, sir.
Okay, cool. Okay, let me write this. And then there is something that is of important that I want to explain today. We are now climbing the ladder based on where we left from yesterday. So 3n. So this is 3n here. 3n and then the thing -1. So yesterday, as I was saying on the WhatsApp group, I said there's some questions whereby I told you to jump them. Do you still remember? It was E, I don't know, K or the way 3. I think so. I or J, I'm not sure, quite sure. Do you still remember? I said those ones which are of larger numbers, I said you must jump them and get. Guys, do you still understand? Seems like
Sir, we do.
yes. So since now you understand those ones whereby you can determine the number of terms, the shorter ones. So this one, look at this one. Let's determine the number of terms. So today's session, I'm gonna show you how to determine the sum of those big numbers, taking in consideration that even those ones that I said you must jump yesterday, you must not do. I think there were 3. Well, on this session where I'm writing now, this example, it will be specifically based on those ones which I said you must jump. Because me saying you must jump those ones, I wanted to prepare you for the basic ones. After you now know the basic ones, we go to those ones which I said you must jump. So now let's determine the number of terms here. I said for you to determine the number of terms, you say the number at the top of the sigma, which is 100. You always subtract the number at the bottom of the sigma, which is 3. And then you always add 1. Then you're going to get the number of terms. So n, it's equals to 100 minus 3. That's 777. That's 97. 97. Yeah, 97 plus 1, it's 98.
98.
Yeah. So can you see here we are having a 98 terms, of which is totally going to be different from this one. This one, if you still remember, we got 6 terms. So if it's 6 terms, it's too small. So it's very easy for you to determine the sum because this one is very too small. The number of terms there are 6. That's why we utilize that concept. But what will happen if you get the number of terms as in like 98? To those who don't understand, coming again, I showed you the formula to say for you to determine the number of terms, you say the number at the top of the sigma, which is 100. You subtract the number at the bottom of the sigma, which is 3. You always add 1. So we are getting n is equals to 98. So it simply means to say there are 98 terms. Ne? And then this question, it wants us, because they're saying evaluate here. Evaluate means you must find the sigma. Sigma means you must find the sum. So we must find the sum of those evaluate. So we must find the sum of those 98 terms. So in this regard, they are main. And then it simply means to say we must develop a series. After developing a series, we must check whether it's a geometric or arithmetic. If it's an arithmetic sequence, then since you understand that you are working with the sum, because of that sigma notation. If this series or sequence is going to be an arithmetic series, yeah. Okay, let me explain something again. When I'm saying arithmetic sequence, you must expect commas in between the terms. But if I'm going to say arithmetic series, you must have plus signs in between. Yet the common difference it will be the same. Now let's develop the series. As developing the series, in this case, we might not do all of those up until 98. Let's do only 4. But take in consideration that I told you that you must always start here. Okay, there's someone, I don't know, there's background noise. Okay, let me mute all of those. Ne? Okay. As I was saying, we always start at this one, right? So this basically means to say, I'm going to say n is equals to 3, right? I'm going to say n is equals to 4. I'm going to say n is equals to 5. And let's lastly do n is equals to 6. I was not supposed to end at 6, but it simply means to say there are a lot of those, so I can't reach 98. I will be wasting time in an exam. Then, now you're developing a series. Remember, when you develop a series, it will be what? It will be brace 3 into 3n, so to say minus 1. And then I'm going to say plus brace, you say 3n minus 1. Plus brace 3n minus 1. Plus brace into 3n minus 1. So this one, we're going to substitute. The first one, we're going to substitute for n is equals to 3. So where there is n, we're going to substitute by 3. So here we are having 3. You write the 3 CDs. So the one that we are substituting, I'm going to write it with a different color. So here it will be 3 because we are substituting for n is equals to 3. And then you continue. It's minus 1. You say brace plus, then you say brace, you write 3. And then for this one, we're going to substitute n is equals to 4. Just like that. Then you continue with the formula that will be minus 1. Plus, open, brace 3. And then this one, we're going to substitute for n. We're going to substitute equals to 5. So here you write 5. And then minus 1 plus brace 3 open bracket. There is a reason why yesterday the ones which include large numbers, I said you must leave them. It was specifically for the purpose of this video, because if I can teach you everything at a go, you won't understand. You'll get confused. Right? And then if that's the case, then you now write 3 times 3, we all know that is 9. 9 minus 1, that will be 8. Right? Then you say plus on the second part, 3 times 4, it's 4, 8, 12. 12 minus 1 is 11. You write 11. Plus on the third part, 3 times 5 is 15. 15 minus 1 is 14. So you're going to write 14. Plus 3 times 6, 6, 12, 18, that's 18. 18 minus 1, that is going to be what? 17. Plus, you can continue and so forth up until we reach 98. But I can't do all of them. Any questions?
Sir, yes.
Yes.
The part where you have used when you were using the green pen,
Yes.
n minus 100 negative 3 plus 1.
Come again?
How n is equals to 100 minus 3 plus 1.
Yeah. Okay, I see it now. Yes.
Yes. How come is it that your 3 is negative and your 1 is positive? Isn't it supposed to be the other way around?
No.
The signs.
No, it's correct. I always told you that you must always say the number at the top of the sigma 100. You write 100. You subtract the number at the bottom of the sigma 3. You subtract 3. And then I always said you must add 1 if you still remember. So it's a number on top, which is 100, minus number at the bottom, you always add 1. So it's 100 minus 3 plus 1. That's the formula.
Okay.
Yeah. Then now let's continue, guys. And then from there, I told you again, when we are speaking about a sequence, you must have commas in between. But if it's a series, it must have plus signs in between. And you can get arithmetic sequence. It simply means to say you will get a common difference in between the sequence because you'll be having commas. But in this regard, 8 plus 11 plus 14 plus 17, that's not a sequence. But it's a what? It's an arithmetic series. Okay, before that, I'm saying it's an arithmetic series. Let me justify my answer. Let's find the common difference. So you get the common difference. Don't forget, you get the, okay, let me do like this. Don't forget, you get the common difference by just saying, okay, before that, this will be T1. If you still remember, that will be T2 in the series. T2 in the series. That will be T3 in the series. Lastly, that will be T4 in the series. Now let's check. You say T2 minus T1. That will be 11 minus 8. You get 3. You write 3 here.
3.
Yes. Let me write it properly. Then you say 14 minus 11. You get 3. And then you say 17 minus 14. You get 3. So this basically means to say this is not an arithmetic sequence, but it's an arithmetic series. Why is it a series? It has plus signs in between.
Yes, sir.
Yes, it's an arithmetic series. So since now it's an arithmetic, hey, my handwriting. Sorry for that. Since now it's an arithmetic series, it's because it has a common series. It's because of it has a common difference. We got d equals to 3. So since this is an arithmetic series and they want the sigma, sigma means the summation. It simply means to say, you will find what? The sum. Using the formula for the sum of the arithmetic series. I told you. And another thing that one can do, let me show you something. Ne? Wabana here, this is still continuing. You can as well get the last term here. You can say plus, you leave it, dot, 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 plus. Your last term, it will be what here? It will be 3. Because if the number of terms, it's what? It's 98. It simply means to say, how best can I explain this?
3 times 98.
It's, oh yeah, it simply means to say the last time it's n is equals to 100. We are not guessing. I'm gonna go back and show you how. Why am I saying n is equals to 100? So remember, I told you, let's go back a bit. 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 Yeah, here. Do you see this part? Where I said this is the number that you end with. Always here. The number that is at the top of the sigma, I said you end with it. The one that is at the bottom of the sigma, I said you start with it. So when I'm saying you end with it, it simply means to say that will be the end in that series. Then now since you understand that, it simply means to say n is equals to 100 because it's the one that we're going to end with it. And then in that regard, we know that we're having it on the formula 3. So it will be 3, open bracket, our n is 100. So you'll say 100, and then you minus 1. And then plus, dot, 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 plus. And then you all know that 3 times 100 is 300. 300 minus 1, that's 299. Do you all understand this? You'll see why.
Yes, sir.
Okay, cool. You'll see why I'm showing you this 299. It's very important. This 299, guys, it's very important, this one. Do you know why? It represents what we call the last term in that series. It represents the last term in that series. Let me show you, mates. It represents the last term in that series. And then, since this represents the last term in that series, and you understand that you are working with arithmetic series, it simply means to say you're going to use the formula for the sum of the number of terms of the arithmetic series. Take into consideration that this formula that I'm going to write is the formula that you use when you are given big numbers. So remember, I said you're having this one. Sn, it's equals to n over 2. If you still remember where I taught basics. Brace into 2a plus n minus 1d. So we are not going to only use this one. You can as well use it, but don't use this one. Since you know maths, you're going to use this one that I'm going to write with the green color. So you're going to use Sn, it's equals to n over 2. N over 2 raised into a plus L. Do you know why I'm saying you must use this one? Do you know why I'm saying you must use this one? It's because L represents the last term. And then the last term we have it. L represents the last term. The last term, we have it. That is 299 that we recently got. So the last term is this one here that I wrote, 299. And then now let's solve that. Now in solving that, I'm going to say Sn, it's equals to. So if I can ask you, how many number of terms are we having? So remember that n is going to be 100. And get, so you'll write 100 here. Over 2. Raise, and then your a is the first term. Is the one that is represented on the series. So the one that is represented on the series. That should be what? 2. A is equals to 2. We got 2, ne? Was it 2? How much did you?
3. It's 3. It's 3.
It's 3, ne?
Yes, it's 3.
But, okay, just a second. Maybe there's something that I did wrong. I was explaining correct. Oh, yeah.
Is it not 8?
It should be 8.
Isn't it 8?
It should be 8.
8, yeah.
Yeah, it should be 8. Do you know why I'm saying it should be 8? We are not guessing. Do you know why? It's because of 8 represents your first term. Q1. Laibona, ne? Yes. So that should be 8 here. And then plus. And then this L is the last term. So that one, I think all of you know it. That last term we got 299. So you write 299 here. You'll say 299. So do you see why is it of importance that we use this formula? We use it only if they want the sum of those number of terms which are many, ne? Of which this is S of 100. It equals to, okay, let me show you something. There's something. Wait a minute. How many number of terms? There must not be even 100. Since now we understand that
98.
Yeah, it's 98. Since now we understand that we are having 98 terms, it simply means to say in a place of n, I must not put 100. I must put what? I must put 98.
98.
Yeah. Do you see? Even when you are making a mistake, you will still be able to correct yourself. So, okay, let's write it properly now. But at least you have a clue on what's happening. So since we're having 98 terms, it will be S98, not S100, because we're having 98 terms. Because how I got 98, you say number at the top of the sigma minus number at the bottom of the sigma, you always add 1. So that will be 98 here. You divide by 2, because you divide by 8. No, it's 2. Because 2 is from the formula, sorry. Yeah. And then you say brace. Here, A, it's 8 because that's your first term of the series. And then you say plus. And then the last term, what did we get? We got 299. Anger. You write 299. Yeah, now we are 100% correct. So you say S98 because we're having 98 terms. It's equals to, what is 98 divided by 2?
49.
Eh?
49, sir.
Okay, you'll write.
49.
Cool, 49. And then open bracket. What is 8 plus 299? Is it 3 of 7?
Yes, sir.
Yeah, 307. Then multiply 49 times 307. Let's see how much do you get. Therefore, sum of 98 terms.
It's 15,043.
Yes. 15,043.
Yes, sir.
As in like this. Yeah?
Yes.
Yeah.
Sir.
It means to say this is the correct answer. Any question?
So, sir, can I please ask
Yes.
the formula for arithmetic series and sequence are different?
Yes, they are different. The one for arithmetic series, you must have a common difference. The one for for geometric, you must have common ratio. If in that series, we were having a concept of a series that will give us a geometric series, it simply means to say, please repeat on how you got the last term. Okay. I'm just gonna repeat.